Hi guys, it's Sugar. We are back with another Kaggle competition. We will be solving US patent phrase-to-phrase matching competition. You can see it right here. I will explain everything word by word, line by line, so that you don't miss anything and have a clear understanding of what's going on. If you stay until the end, you will learn all the tricks and strategies I used to solve this Kaggle competition, and you will have made your own Kaggle submission. You can use such projects to strengthen your portfolio as an engineer or developer. You can use it to improve your Kaggle profile, and most importantly, you will learn how to approach and solve such problems. Before we begin, if you like what you see, you can click the like button and subscribe. Which competition should I solve next? Let me know in the comments. Enough talking, let's get into it. Now we are at the main page of the competition. As you can see, US patent phrase-to-phrase matching. And we have the description, what is the reason for this description, what we are going to do. We will train models on a novel semantic similar to Datasets. We will extract relevant information by matching key phrases and patent documents. Matching is our main aim. We have the evaluation part. Results are evaluated by Pearson correlation coefficient. This is important because we will use it to test our model. And we have the timeline, we have the prizes, code requirements, and blah, blah, blah. Let's look at the data. So it may ask you to click to join competition. Just do that, it is okay. I already joined it, so it didn't ask me. So we have the sample submission file. This is how our submission file should look like. We have the test file. We have IDs for every data sample. We have the anchors. We have the targets, and we have the context. Okay. We will match anchor with targets. Now let's go to the train file. We have similar data, ID, anchor, target. Context, what is different from the test is we have the scores. Obviously, this is our target. This is what we are trying to predict. We will get over the data in the code a bit more. So to start this competition, you should click this code and say new notebook. Here we have the new notebook. There are a few things that we want to do first. The first thing is we got to have the internet off, because for this competition the internet must be off. After that, we have the main data, but we will use additional data too, so we will add those. First thing we want to add is we will use Dataset. Okay, so we have to add that to load it. We cannot access the internet. So we click Add Dataset to Dataset v3 base. And after that, we will use additional data too. We will use it to merge it with our main data and make better predictions. And this data is about corporate patent classification, so we add this to the dataset too. And you should see 3 files in the input. Okay, now let's get into the code. This doesn't do much. This cell comes built in. It just shows you the files. We can just delete it. And let's start with importing the necessary libraries. First, we will need pandas. After that, we will need transformers. We will need some other libraries from transformers, which is Dataset v2, Tokenizer. We will use fast. We will need Dataset v2 for sequence classification. So we are importing v2 because basically we can load v2 into the v2 libraries. We can import v3 to the v2 libraries. So it is okay if you do it like this. After that, we will need torch. We will import Optim from torch. We will import Dataset, Dataloader, and stuff from torch.utils.data. We are going to import Dataloader and Dataset and a random split. Okay. Again, from not torch but torch metrics. Dot regression. We are going to import Pearson correlation coefficient I mentioned in the beginning. Now this is evaluated by Pearson correlation coefficient, so we are going to need it. This is just regression. Okay. After that, from NumPy, we will need NumPy, we will need random, we will need time it to evaluate the time. And from 2QDM, we will import 2QDM. Let's run this. No module named transformers because this is transformers. Okay. Next, we want to define the hyperparameters, and we want to make sure that there is reproducibility. So we will set the random seeds and define the hyperparameters. I will give a random seed. I will give a model path, which directs to our Data v3 base. Okay. For that, we give Kaggle inputs and Data v3 base. We are going to have a max length, 256 is fine. Batch size, I will give 64. 64 is enough for the GPU we're going to use. And learning rate, I will give it 2e-5. You can change it if you like. For epochs, I will train it for 2 epochs. And for the reproducibility, let's set the random seed. Okay, for random, now it's for NumPy. It's random seed again. Okay, it's now for torch. Manual seed, random seed. Let's just copy this, not type it again and again. Torch tutor manual seed. Okay, torch tutor manual seed all. Torch backends qdnm deterministic equals to true. Torch backends qdnm benchmark equals to false. After that, we have to set our device, whether we are going to use CPU or GPU. CUDA if torch CUDA that is available. Else, we are going to use CPU. Transformers.utils.logging.set where positive error. What this does is it just suspends the unnecessary transformers errors, warnings, stuff like that. So this is all done. Now we are going to load our data. So first we are going to load our train data. We do it by pandas.read CSV. For that we can just go here, go to train CSV and copy the file path. We put it here and we load testdf, read CSV. For that, let's go here and load the test CSV. We are going to load the submission df, again pandas read CSV. Let's go and copy that, sample submission. Oops. Okay, and we have the additional data. We have to load that too. Patent df equals to pd.read CSV, and it is here. Titles.csv. We put them here, we defined those. Okay, now let's actually look at the data. let's go to the train df's hat. Like we discussed, we have the anchor, we have the target, we are going to match those, we have the context, and we have the score. Again, let's do this for the test df. Test df.hat. The only difference is we don't have the scores. Let's do it for submission df. This is how our submissions supposed to look like. And lastly, let's go for the patents df. Patents df. No, let's change this name to patents, okay? Patents df.hat. We have the code which corresponds to the context of our main dataset. We have the title, section, class, and blah blah. Okay, we don't need the rest. After that is done, we are going to merge the patents with our main data. So let's merge with the train data first. For that, we do merge train df equals to train df.merge. We are going to merge it with patents df, and we are going to merge according to the context of our main data and section, code of the patents data. So how we do that is we say left on equals the context, which corresponds to our main data, and we say right on equals the code, which is for the patent data. This merges those two data sets so that they overlap. After that, we are going to create a new column for the updated train df. There's a typo here. Updated train df. The name of the new column is input. Again, we go to the update train df. We take the title, which is this, we take the title and we put an empty space, and we go to we add the updated train df, and we add the anchor from the original dataset. And it is here, okay? So we basically merged them to get we added an additional data to it so that we can make better training and predictions. Let's actually take a look at how our latest dataset looks like. So as you can see, we have a new column named input, which combines this and the anchor. Okay, and another thing that you should notice is that we merge context with code. Now let's look at the context and the code. See, they are overlapping because of this. We did it for train, now we are going to do it for the test. We can do it like just copy this all, okay. Instead of train, we are going to say test. The rest is the same, okay. Patents df, left on, right on, updated. Test df, updated. Test df, again updated. Test df, and we want the tail of the updated test df. Okay, let's look at it again. Let's make sure, yeah, see there's a typo, this is supposed to be test. Okay, there it is now. So input is mechanical metal blah blah blah, we merged it with anchor, context, and codes overlap, so we are good to go. Now it's time to load our tokenizer and our model. We load our tokenizer with the Berta v2 tokenizer fast that from pre-trained. Okay, we define the path to that, which is here, model path. We can just put that here, model path. Now for the model, we say delta v2 for sequence classification. We will take this task as a sequence classification to find the similarities. Model path. But additionally, what we're going to do is we say number of labels equals to 1. What this does is we are doing a classification, but it is actually a regression. We will return a number. We will return an integer or float or okay. We will return a number. So since this is a regression problem, we have to say that to the model, and that's how we say it. If number of labels is 1, this is a regression problem, and we put this to the device, if it is CPU or GPU or whatever. Okay, probably we made a typo. Model path. Okay, let's just go there and copy this. Let's run this again. Run this again. Got an unexpected because we forgot from pre-trained. Okay, this warning is okay, it's fine. It will load the model and the tokenizer. So it works correctly. Now we will go to the dataset. We have to define two datasets. First one is for train and the second one is doing the testing and the submission. So let's start with the train dataset, okay? Phrase train dataset is what I'm going to call it. We will put the dataset as its argument. Since it is a PyTorch dataset, we will need init, get item, and length minimum. Let's start by init. We will give self, we will give inputs, we will give targets, and we will give scores. At last, we will give tokenizer. Let's give the scores to this scores, and we will do the encoding. So there's an interesting thing here, okay? To tokenizer, we will give two inputs. First one is inputs and the second one is targets. What this does is it takes them two and puts a SEP special token between two and tokenizes, kind of like combines them. You might not see it much, but this is what it does, okay? After that, we will give it padding, which is true, truncation, which is true, and let's give the max length equals the max length. Okay. We have to define the get item. This is what this does is given an index, we want to return an object, that specific index. How we are going to do is first we will define a dictionary. We will say k will be the item and the will be the key and the value will be the torch that tensor value. We will take the index. We will take for key and value in self that encodings that items. So what we did is we take the values and we make them torch tensors because we are going to load them into the PyTorch loop. Now we again take the outtick. We will put scores in it because that's how we are going to calculate the loss. For that we can just give scores and index. Lastly, we have to define the length. We don't take any arguments for that, we just return the length of the scores since it is equal to the length of the whole dataset. Okay, let's run this. Now it's time for the test dataset. I will call it class phrase test class submit dataset, because we are going to use it for submission. Again, we give the dataset pretty much same logic. We give init, self, inputs, targets. What is the difference is, I showed it to you. We don't have scores in the test. That's what we are trying to predict. Instead of that, I will give the IDs so that I can match it in the submission file. I will show you the submission file too. So we give IDs, and at last we give Tokenizer. Instead of scores, we put IDs into this variable, and the rest is same. We have the encodings, inputs, targets, padding, and max length. Now define getItem, self and index, pretty much same logic. Instead of IDs, instead of scores, we will put IDs. Yeah, the rest is the same. Again, for the length, instead of scores, we will return IDs, length self.IDs. Okay. Now let's actually see if they work or not. Let's create a dataset, phrase train dataset. We give updated train df. This is our train dataset. We give input and we turn it into list. Again, our train data, we give target and we put that into list. Okay. What else we need after the target? We need scores. It's going to be just score. Let me put this to here. Score to lists, and as last we will give Tokenizer. Okay. Okay, updated train, score to list, Tokenizer. Everything seems fine for this. Now let's go for the test data set. Phrase submit dataset updated test df. Give input to list. Now let's copy this. Okay, let's make sure we call it input. Okay. We may have some typos. No, it is okay. Input target. As last, you will have IDs. Okay, let's go over here. Let's make this IDs and Tokenizer. Tokenizer. Okay. Okay, we define them both. Now let's actually see them in action. Let's multiply it by this 30 so that it is like a clear print. We can see what's going on. Let's take the length of the data set and see it works. Let's see the get item works for train. And let's put a separator again. Let's see that test data set train works. Let's see test data set get item works. Let's print this, boys. Yeah, we have an error. It says no IDs because it is just ID. Let's run this again. Has no attribute scores. Okay, where did we do that? Okay, this is not scores. Okay, this is IDs. Let's make sure not. Okay. Okay, we forgot to return it. Turn out deck. Don't forget to return statements. Out deck. Let's run this again. And now we are talking. We have the length, we have the input IDs, token type IDs, attention masks, and additionally we add the scores here for the train and IDs for the test. Let's look at that. Length of the test, input IDs, token type IDs, attention mask, and IDs. So our datasets are working as we want. Now let's turn them into Dataloader and split them to train and validation. Do it by generator. You could torch that generator. We gotta give them manual seed of random seed. Okay, we will use it to split our dataset, train dataset and validation dataset. Because the random split we imported in the beginning is split datasets. I want to give 0.9 to train, 0.1 to test. So that's I put that. And generator is generator we defined. Okay, now let's load them, turn them into data loaders. Train data loader equals the data loader. We give datasets, which is train datasets. We give batch size is batch size. We define that too. Oops. And shuffle. I want to shuffle this. This is for train. We will do it for validation and we will do it for test. Train. This is validation. Well, dataset. I want to shuffle this too. But for test, I don't want to shuffle. Just keep things as they are. And the rest stays the same. Shuffle is false. Let's run this. And it works. Now it's time for the training loop. Are you ready? I am. Let's define our optimizer. We will use add-on-v, add-on-v. We put model.parameters. We have our learning rate. As we discussed, we will evaluate it by Pearson correlation coefficient. Pearson coef. Okay. So I wanna estimate the time. This is optional, but I like doing it. This is the starting time. Time it. That's default timer. Okay. For epoch in TQDM range of epochs, how many epochs you have depends. We have 2. Position 0, leave true. This prevents TQDM to print new lines at every single iteration. Now let's put the model on train mode. Because we are training the model, we have to do that. We have train running loss. This is our total loss. And let's iterate the data sets. We'll have index and sample and enumerate. Yeah, let's put TQDM train data loader. Okay. Position equals to 0, same things. Leave equals to true. Now we are in the loop and we can start getting the necessary elements from our sample. First thing we are going to get is the input IDs. We will feed these to the model. And since we are going to feed them to the model, we put them whatever device we are working on. And after that, we will have attention mask. Again, we go to sample and attention mask. Again, we are going to put it to model, so we put it to device. Same for targets, sample, this is scores in this case. And we put it to device. Okay, now we are ready to get outputs from the model. Input IDs, input IDs. Attention mask equals to attention mask, and labels are targets. After we get that, our loss value will be outputs.loss. That's how we get the loss value from the output of the model. Now we want to make sure that training is happening. We do that by optimizer.zero grad loss.backward and optimizer.step train, and we want to update the loss, train learning loss plus equals the loss.item. That's how we get the value from the loss. At last, we want to take the final loss. When we take the running loss, we divide it by index plus 1. We did the training and we had a validation set. So we had to see that model is progressing, we actually need to see the loss for the validation data set. So we are going to do that. Since no training going to take place, we say model eval, we put it evaluation mode. Model running loss, again 0, we will have predictions. And we will have the gold values, which are the grant truths. Since there are no training, we say torch.noGrad. This makes sure that no training is happening. If so, why it does like that? No torch.noGrad. Okay, so that no wasted resources and computation power, etc. Again, for index and sample and enumerate TQDM, well, Dataloader, position equals to 0, layer equals to true, input IDs equals to sample, input IDs to device. Attention, okay, let's just copy it from here, okay. These are just fine. Okay. Okay. This is also fine. Okay, now we have to store the predictions and the gold values. How we are going to do that is we will extend our preds. We will store our values as floats. For in outputs, we will take logits where our predictions are stored. We will squeeze them because we don't want the additional batch dimension. So that eliminates it. Well, let's put this to here. Okay. Do the same for golds. Extend. Floats I for I in targets. Now let's update the running loss. Outputs that loss that item. Okay, we just didn't do this, went directly to this. It's time for final validation loss. Well, running loss divided by index plus 1. The question is, why did we store these predictions and goals? Because we want to print the Pearson scores. For every epoch, let's print this. Prettily. Print, first let's print the Pearson score. Pearson score. How we calculate the Pearson score is, first we want a float. Okay, it's originally turns a torch tensor, but we want float. Torch the tensor, prets, we turn them into tensor first, and again torch the tensor, goals. Okay, and let's take the 4 digits from and let's put this. Yeah, let's print f train loss per epoch is epoch plus 1 train loss. I just want the last 4 digits. That's why I put that for f. If you want all the digits, you can just, remove it. It's optional. I like it this way. Let's do this for validation. Epoch plus 1. Okay. We store it in val loss. Let's print the closing mark. After that, let's take our time. As you remember, we started a timer. Let's calculate how much time have passed. Training time. Stop minus starts. 2 digits are enough. This will be in terms of seconds. Close it. Before running that, currently we are on CPU. We want to change things to GPU. For that, go to here, the right panel. Go to accelerator, select whatever GPU you want. I use P100. Okay. Come here, say run, or just go here and say run all. It will start the training. Once it is done, let's meet here. If we have any bugs in the training loop, we will solve that first. Now we encountered with a typo. I wrote inputs here. No, it is input IDs. Let's run it again, and if you don't encounter with any bugs, let's meet here again after the training. Now the training is done and we are back. If you followed me step by step, you should have no problem with this. So let's look at the values. Valid loss increased slightly, which is something we don't want. Train loss decreased, it is fine, and we have a higher Pearson score. So we can say that learning has happened. Okay, model is learning and everything is fine. Before getting into the submission, first we have to empty the CUDA. Because we have some variables and stuff stored in the CUDA. This may throw a CUDA out of memory error. We don't want that, so we do this. Now let's get the values for our submission file. Again, we will have prets and we will have IDs. We take the model to evaluation mode because we will do testing, we will do predictions. Again with torch that no grad, so that no training will happen. For index and sample in enumerate, TQDM, test Dataloader. Position equals to 0 and leave equals to true. Same procedure, more or less. Again, we need input IDs, we take it from sample, input IDs, we put it to device. After that, we need attention mask. We take sample attention mask and we put it to device. At last, we need to IDs. We do IDs extend, we take IDs from the sample. Now it's time for the prediction. We put the model input IDs equals the input IDs. Attention mask equals the attention mask. And we'll update our predictions, pred list. We say pred extend. Pred extend, okay. Float, we put the float here. For I in outputs logits, which stores the predictions. We put the squeeze because we don't want the additional batch dimension. This eliminates that. Let's run this. Okay, object2, there's no attribute. What's this? No, this is model.eval. Okay, this Kaggle notebook does that sometimes by itself. Okay, name outputs, out. There's a typo. Outputs.logit. And our prediction is done. Now we have to create a submission file. We do that by submission df. We create a new data frame. We put lists. We take zip, IDs, and preds. And as columns. Let's check our submission df. ID and score. Okay. They have to be identical. And score. Okay. Now submission df because we want a CSV file and our name has to be submission.csv. We have to put index equal to false. And let's actually check our submission df.head to what it looks like. Name columns, because this is equal. Okay. See, it is identical to the requested format with submission df. Now we have the submission.csv file. Now it's time to submit it and get our score. So to submit that, what you need to do is we have to go to here, the right panel. You have to click submit and just click submit. Okay. A pane will open up from the left bottom. This will be done in around 15 minutes. It basically runs the whole notebook and after that it will do the scoring. And let's meet here after this is done. Now we are back. As you can see, this run is successful and this scoring is complete too. Let's check. Let's just click it. And here are the results, your private and public scores. If you did everything as I showed you, you should have your scores ready. Okay. I will put this notebook to the description. You can just come and check it out, or you can code yourself with me. And that's all. That's it for today. I hope you liked the video. Don't forget to subscribe to my channel. Until next time.